The next instruction under string instruction group is REP or REPE, REP2 or REPNE or REPNZ. So you can use this, basically this is a prefix that is used before any string instruction. For example, if I am moving MOVSB is the instruction. Suppose this is the instruction which means moving a byte from the data segment to the extra segment, and for this instruction, if I am using the prefix REP, if I'm using the prefix REP with this instruction, for example, here it is also written REP MOV SB, means the byte will keep on moving from the data segment to the extra segment until the CX gets 0, until the content of CX gets 0. So for number of bytes to be moved from data segment to extra segment, here if I want to move 4 bytes from data segment to extra segment, so I'll be loading the counter, that is I will be loading the CX with 404H, and I'll be using this instruction with REP prefix, and it will keep on moving the byte from data segment to extra segment until CX gets 0. So after 1 byte move, CX will get decremented, and again the transfer of the byte will take place from data segment to extra segment, and it will keep on repeating till CX gets 0. So here are the conditions mentioned. If REP is used as prefix with the string instruction, then that instruction will keep on working until CX gets 0. If REPE or REPZ instruction is used as a prefix with the string instruction, then that instruction will keep on working until the condition CX gets 0 or 0 flag gets 0. And if REPNE or REPNZ is used as a prefix before any string instruction, then that instruction will keep on working until CX gets 0 or 0 flag gets 1. Now the next instruction under string group is LODS or LODSB or LODSW instruction. So what does this instruction do? This instruction copies a byte from a string location, means from a location in the data segment whose offset is given by the source index. The offset is given by the source index, so it copies a byte from a string location pointed by the source index to AL, or it copies a word from the data segment whose offset is given by source index to AX register, and it does not affect any flag. And again same thing, if a byte is going to get copied from data segment to AL, then we're going to use LODSB, and if a word is going to get copied from data segment to AX register, then we're going to use LODSW. Okay, the next instruction that I'm going to talk about is STOS or STOSB or STOSW. So how does this instruction works? It copies a byte from AL or a word from AX to a memory location in the extra segment. Again I am repeating, if a byte transfer is going to take place from AL register to extra segment, whose to a location in the extra segment whose offset is given by destination index register, then we are going to use STOSB. And if we are using the instruction STOSW, then what does this instruction will do? It will copy the content from AX register, that is 16-bit accumulator, to a location in the extra segment whose offset is given by the destination index register. So again, once the byte gets copied or a word gets copied, the destination index get automatically incremented by 1 for a byte move, or incremented by 2 for a word move, or decremented by 1 for a byte move, or decremented by 2 for a word move, depending upon the status of the direction flag. Again, it does not affect any flags. STOS instruction also does not affect any flags because it is a simple data transfer operation. And same thing, if the direction flag is 0, then di will automatically be incremented by 1 for a byte move, or incremented by 2 for a word move. And if the direction flag is 1, then di will automatically be decremented by 1 for a byte move, or decremented by 2 for a word move. The next instruction that I'm going to talk about under string transfer group is CMPS or CMPSB or CMPSW instruction. So what does this instruction do? It compares. What does this instruction do? This compare instruction compares the content in the data segment with the content in the extra segment. So what happens, we have data segment and we have extra segment, and the byte or the word that is going to get compared from the data segment, the offset of that byte or word is given by source index register, and the byte which is going to get compared in the extra segment, the offset of that byte or word is given by the destination index register. So what happens, this is the source string, this data segment is the source string, and the extra segment is the destination string. So if a byte is going to get compared, we're going to use CMPSB, and what happens, a byte is going to get compared from the data segment with that of the extra segment, and if a word is going to get compared, then the instruction that we're going to use is CMPSW. Now, how the comparison is done? The comparison is done by subtracting the byte or word that is pointed to by the destination index in the extra segment from the byte or word in the data segment whose offset is given by the source index. And accordingly, the flags will get affected. All the 6 flags will get affected, and there is no effect in the operand, and the result will not get stored. What happens, again I am repeating, what will happen if a byte is going to get compared? So how the byte will get compared? The byte from the extra segment will get subtracted from the byte from the data segment whose offset is given by source index in data segment, and the offset of that byte in extra segment is given by destination index. Then what will happen after the subtraction process? Flags will get affected and the result will get discarded. Similarly, same operation will happen for the word comparison. Now again, if there is a string of data and we need to compare the string of data, so depending upon the status of the direction flag, the source index and the destination index will get incremented or decremented accordingly. And we need to what happened after the comparison? Source index and destination index will be automatically incremented or decremented according to the direction flag to point to the next element in the 2 strings, that is data segment and extra segment. And CS will function as a counter which is decremented after each comparison, and if we use REP instruction along with this CMPSB or CMPSW instruction, then the comparison will keep on continue until the CX, that is the counter, gets 0. The last instruction that I am going to talk about in the string transfer group is SCAS or SCASB or SCASW instruction. So what happens in this instruction? It compares a string byte with a byte in AL or a string word with a word in the AX. So this instruction affects the flag, but it does not change either the operand in AL or AX or the operand in the string. The string to be scanned must be in the extra segment, and destination index must contain the offset of the byte or the word to be compared. So after comparison, destination index will be automatically incremented or decremented according to the direction flag. Obviously, and CX will work as a counter, and which is decremented after each comparison, and it will go on. This process of comparison will keep on continuing until CX gets 0. So SCAS instruction affects all the 6 flags. So here also the comparison means from the source string or from the source content, the destination content will get subtracted, and according to the result, flags will get affected and the result will get discarded. So the comparison process here is also same. So the comparison will occur, as I've told you, it will occur between the accumulator and the extra segment, and extra segment, the offset of the byte or the word which is going to get compared, the offset of the byte or word which is going to get compared in the extra segment, that offset is given by the destination index, and the to which it will get compared, that is stored in AX or AL register. If a byte is going to get compared, then it will get compared with AL register. If a word is going to get compared, then it will get compared with AX register. So this was all about string transfer group instructions. I'm ending this class here. Thank you.